Hello everybody, and once again welcome to Pankaj's Echelon Tutorials. In this today's session, we are going to do a couple of problems related to probability, and we are dealing with the IGCSE curriculum, the 10th grade. The subject is International Mathematics. The code of this subject is 0607. And as I told you, the topic is probability. And I'm going to solve quickly some uh, two problems based on relative frequency and probability. Since I've already discussed the theory of this relative frequency and probability, so now I'm not going to discuss more in detail, but I'm going to solve these two problems quickly for you. Okay, so let us get started. And the very first problem that you can see on the screen is this one, right? Example number one. It says that the bus monitored 40 times in its journey from A to B. It was seen that the relative frequency of the bus getting late was 0.3. Okay. How many times the bus was late? So two things are given to you in this particular question. That is, the bus was monitored 40 times and the relative frequency of the bus getting late is 0.3. And they have asked you how many times the bus was late. Now, in probability, you are supposed to interpret the question in a very correct way. Okay, if your interpretation is correct, no doubt you will not be going wrong in the solution. Okay, but if you somehow understand or interpret the question slightly wrong, then you will mess up with everything. Okay, that's very important about this probability. So let us interpret this question. He says that a bus was monitored 40 times in its journey from A to B, and it was seen that the relative frequency of this journey of the bus getting late. So, normally any bus, travels from A to B, okay, and the time, taken from A to B has to be fixed, okay. But then, due to some inevitable circumstances, due to some reasons, the bus gets late, maybe because of the traffic or maybe some other reason, the bus normally gets late. So it's a common observation that many a times a journey which is having a fixed time from A to B, you may see that the journey of the bus is getting late also. So 40 times this observed this journey from A to B of this bus. So we can say that n, that is the number of trials, is equal to 40. Okay, or you can say the survey that is taken, okay, for how many times the survey was conducted, that is your n. So that is 40. Okay, now this is the solution that I'm doing. So 40 times is your n. Now in this 40 times, many a times the bus must have reached well in time, many a times it must have been late. Okay, so whoever has done this survey, he must have observed how many times the bus is getting late in this 40 observations. So this, how many times the bus has got late, this is our S. Okay, this is what we want to find out. So S is something which we have to find out. That is the question. How many times the bus was late in this 40 times journey that was conducted. Now one more thing is given, the relative frequency. So I'll write the relative frequency of the bus getting late. So we can write this way, RF bracket late. This is equal to 0.3. Okay. Now with these three things that you have picked up from the problem, that is n is 40, relative frequency of getting late is 0.3, and S you have to find out. You can think of a formula that I told you. The formula is relative frequency of a bus getting late will be equal to S divided by n, isn't it? And they have asked you to find out S. So S will be equal to n times relative frequency of the bus getting late. Okay. So S will be equal to n, you can take 40. Relative frequency you can take as 0.3. And 40 into 0.3 happens to be 4 3s are 12. 40 into 0.3 is 12. So 12 is the answer. So S is equal to 12. That means the bus was late. Okay. 12 times. Right? So this is the answer. The bus was late 12 times in this 40 journey that was conducted. Okay. That was question number one. Now let us go to question number two. Question number 2 says that a girl planted some 50 flowers of 3 different colors, and the colors were red, yellow, and white. The table shows the values of some. Uh, some values are shown in this table, and you have to complete the table. So whichever values there's a blank, that you have to fill up, right? So this is the table shown over here. The colors are red, yellow, and white. Frequency, that is out of 50, 16 flowers are red color, 28 flowers are white color. Now, what will be the yellow color flowers ka number? Now, it is obvious the yellow color. So let me write the solution here. So yellow flowers, if you want to find out the number of yellow flowers out of 50, will be obviously 50 minus 16 plus 28, isn't it? This should be the answer, right? And that works out to 6. Okay. So can I write this 6 as the answer for this? This is 6, number of yellow flowers, right? Okay. Now relative frequency for the red flowers is given as 0.32. Okay. Now these two relative frequencies you have to write down. So you have to calculate, or you have to find out what is the relative frequency of yellow and white. So relative frequency of this is given 0.32. So no issue. That is okay. What should be the relative frequency of yellow? So I'll write here relative frequency of yellow flower will be equal to S of yellow, that is number of yellow flowers, okay, divided by the N, that is the total flowers, isn't it? So S of yellow is how much? 6. And N is how much? 50 flowers. So it will be 6 upon 50. Am I right? And this works out to, I think 6 upon 50 should work out to 0.12. Okay. 0. So this has to be the relative frequency of yellow flowers. Now this also you have to fill up. Okay, so this also we can calculate in the same way. Relative frequency of the white flowers will be the total number of white flowers out of 50 divided by the total number of flowers planted, that is 50. So this should work out to 28 upon 50, and this gives you the answer as 0.56, right? 0.56. So the answer for this one will be 0.56. So question number 2A is complete. The table is complete. Now let us see what question number B says. Now the girl decided to plant 125 flowers, the same 3 colors. So now the same girl has decided to plant more flowers. Okay, not 50 but more. So how many? 125. So now your N happens to be 125. Okay. And the question asked is how many yellow flowers she must have planted. So in the same table, like this table, they have not asked you to make an entire table, but the question is how many yellow flowers she must have planted. So the answer for B is this way. This is for A, right? For B, what you have to do is, suppose now N is equal to how much? 125, because she has planted 125 flowers. Okay. And the relative frequency of yellow flowers, okay, will be remaining constant, isn't it? So how much we got relative frequency for yellow flowers in the case of 50 flowers, when 50 flowers are counted, it was 0.12. So now also it will be 0.12 only. But now the number of total number of flowers has become 125. And now they have asked you what is the number of yellow flowers. Okay. So that means they have asked you what is S yellow. Okay. So how many yellow flowers have been planted? This is the question. So very nicely we can use the formula RF for yellow is equal to S for yellow upon N. Okay. This is the total. So we know that RF for yellow is 0.12 equal to S is something that we want to find out. Okay. And this will be now 125 instead of 50. So if you want to find out this, all you have to do is 0.12 times 125 will give you this S, which works out to around 50. So 15 yellow flowers the girl must have planted. So answer is 15 yellow flowers must have been planted by this girl, isn't it? So out of 125, when the total is 125, the number of yellow flowers will be 15. Okay. So these were the two, very short and sweet questions based on relative frequency and probability. In the next video, I'll come up with more of such questions. Okay, so that you get a knack of solving this problem, this type of problems. Okay, so that's all for today. See you in the next video. And if you happen to like my video, please subscribe to my channel so that I'm motivated to make more such videos. Okay, bye. Take care, all of you. See you.